Okay, so welcome everyone. Um, as Mark said, I'm gonna talk about the flight dynamics software we use in GOES and some of the improvement and innovations that we added on specifically for GOES T. So GOES is, as the acronym means, is a geostationary operational environmental satellite. More so, it's a series of satellites operated by NOAA. The current series of GOES satellites consists of 4 GOES R, S, T, and U. GOES R launched in 2016, S in 2018, and most recently GOES T launched in March of 2022, and then we're planning GOES U most likely for 2024. So each of these satellites is in a geostationary orbit. The launch vehicle drops uh, the satellite in a geotransfer orbit, and then the satellite proceeds to slowly raise the orbit until it reaches geo. This sequence that we call launch at orbit racing is what our team focuses on. And to support this mission, we have developed a suite of FreeFlyer scripts with a MATLAB GUI that we call GOES FDS, or the GOES Flight Dynamic System. We've already used it for GOES R, S, and T. So GOES FDS consists of has many functions, but mainly we use FreeFlyer for orbit racing and maneuver planning, for generating orbital event predictions, as we see in the snippet of text underneath. It's an example of things like antenna contacts, spacecraft midnights, eclipses, entering or exiting the Earth shadow, and so on. We also perform individual burn high fidelity modeling and reconstructing or calibrating performed burns, where we take the telemetry from the burn to try to predict what the orbit, or use an alternative orbit solution to calibrate if the engine of the satellite is performing as we expected. So between each launch, we have a cycle of operations, lessons learned, and new development, where we develop new ideas, develop the code, test, and then do our training sessions in preparation for the next launch, in which new ideas developed and go again through this cycle until we do the actual operations of the satellite. In this presentation, we'll talk specifically about 2 improvements that were added to GOES FDS for GOES T. These are the 2-body preliminary ascent planner, which replaced a spreadsheet that was used to plan the semi-major axis and target longitudes at each burn, and the pitch targeting for orbit maneuvers, which was added as we encountered an issue with the way we were targeting burns. First, the 2-body ascent planner. So the preliminary ascent planner is basically a feature that allows us to verify the maneuver plan that the spacecraft vendor supplies us on a very low fidelity model. Usually we only use two-body spacecraft propagation to basically make sense of how much do we need to raise the orbit at each burn, usually the whole sequence from separation to the geostationary orbit takes 10 burns, and each has to occur at a longitude where we have coverage, and after all the maneuvers, we must reach the target desired longitude. And for this purpose, we were using a spreadsheet. It's not the most glamorous, but at least for goes R and goes S, it got the job done. You can see each row indicates a different burn. The um, indicates a different burn until we achieve circularization, and then flipping the apereges and apogees and getting our desired orbit. However, of course, it's not ideal to use a spreadsheet because we can leverage a lot of functionalities of FreeFlyer if we make this improvement. Also, since the code itself is in the cells, then it can be easily corrupted. So we decided to transition from just this spreadsheet to a FreeFlyer mission plan, because it would have a clear interface and use better visualizations. So they developed this a mission plan that will replace all the functionality of the spreadsheet and more. So here we see the comparison of the interface. We have that we input all the required information about the initial orbit and the longitudes that we wish to reach at each burn, and the FreeFlyer would generate the same process that the spreadsheet, the same targeting procedure that the spreadsheet do. Now, even though overall it is an improvement, there are some things nice with the spreadsheet. Sometimes it's easy to edit, and to mimic that functionality, we integrated a custom-made MATLAB GUI using some of the MATLAB interface functionalities that FreeFlyer has. It is as simple as I wrote a show. It is as simple as I show in this snippet of code over here. Just call open MATLAB and call the relevant function. And this is the GUI that we designed to go together with the preliminaries and planner. This allows some interactivity when you can, as you can see here in the, I don't know if you can see my mouse. But basically over here, it's just, with one click, you can edit the target longitude and the relevant values in the ascent plan edit automatically. And this way we can tweak the orbit racing campaign and then ship it back to FreeFlyer, where we can take advantage of all the visualization tools that it offers. So on the left, I showed the plots that we used to do in Excel, and on the right, we have the more advanced visualizations that we can do in FreeFlyer. We can see the whole evolution of the orbit in a 3D environment. We can compare, rather than this simplified plot with the longitudes, we can visualize actually where those burn longitudes line on a world map. You can also generate plots like this, but after having the better ways of visualizing, we realized we didn't even need this type of plot. Here is a better explanation of the world map view. Another functionality that we implemented is we use contact coverage of each ground antenna. So as the FreeFlyer simulation of the maneuver plan goes, it also checks the ground station coverage, and this is what these plots represent. Each line represents the longitudes that any particular ground station covers. So using this map, it is very easy to visualize whether our burns are covered by 2 or more ground stations, which is a requirement that we have for operations. Furthermore, the fact that we developed this new improved method of performing a preliminary ascent plan was very helpful in GOES-T because there was an early abort in LA1, which is the first maneuver in the orbit racing process. After the abort, we had to quickly came up with a new maneuver campaign and various alternative possibilities had to be confirmed and had to check for coverage. We need to guarantee that we will be able to provide 2-station coverage for each of those burns on the new plan. And the preliminary ascent planner was useful to coming up with different possibilities while we were recovering from this contingency. Fortunately, after we replanned the campaign, we only lost about 2 days and there was no other impact in the mission other than taking just a little bit longer in the orbit racing sequence. Next, I'm gonna talk about the other functionality added to FreeFlyer for GOES-R, for GOES-T. And this one is something that we identified during training for GOES-T. So as I mentioned before, the preliminary ascent planner has a very simplified version of orbital mechanics. Next, we go to this is a higher fidelity model when we model more perturbations, and ideally we want to model each burn to occur at both apogee and the relative node of the orbit. The orbit itself is designed so these both will align, and by burning at that location, we can both reduce the eccentricity and the inclination to 0. We're starting a 0 inclination and a circular orbit. However, during training, it was noticed that in some cases, the apogee and the relative node would drift apart. So you had to choose either we burn at the relative node, or we burn at apogee, and this would drift apart with each burn. To the point that if we decide to burn at the relative node, we can achieve 0 inclination, but we cannot achieve our circular orbit. We end up with some eccentricity. Or if we decide to burn at apogee, we end up with a circular orbit with non-zero inclination, which is not ideal. So it raised a bunch of questions because we had already used this software for 2 missions, for GOES-R and GOES-S at this point. And that led to an investigative effort to try to see what was going on. And for this type of analysis questions, FreeFlyer is very useful because the ease of use of developing something in FreeFlyer, we have a spacecraft and study different cases at different starting time with different force models came in very useful. So in these plots, we can see the initial separation for vector for GOES-S and for GOES-T, and how the apogee and the relative node shifted during the circularization phase of the lunar campaign. for Ghost S, both drifted in such a way that they were still close by the end of the sequence. However, for Ghost T, they tended to drift apart and apart until the apogee was about 4 degrees away. Like the right ascension of the apogee was 4 degrees off from the right ascension of the relative node. So it led to the problem that I showed before. And through, as I said, checking different possibilities and different force models, we identified that the reason this happened was due to the moon. Here from the ascent plan is a full fidelity model. The we're propagating on taking only into account orbital J2 perturbations. It doesn't really match what we observe. But once we incorporate the moon, we see what's the main driver behind that drift. So for Ghost T, the relative position for the moon at that date happened to push apart the relative node from the apogee, and that basically explains why it was fine for the Plastug missions, but not for Ghost T. And also using FreeFlyer, we come up with the solution, which was to add a small radial component on each maneuver. Here we see the result of various different angles, and which allowed us to find the precise angle that we needed to align the apogee and the relative node at the end of our or at the point where the apogee and perigee flipped, so we would achieve the zero inclination and circular orbit that we desired. To summarize, the continuous improvement of Ghost FDS has enabled to add new features from Ghost R to Ghost T and to the future for Ghost U. These improvements were directly driven by feedback of using the tools and training with the tools and coming up with the lessons we learned, the limitations that we find, and developing better tools. The powerful capabilities and use of FreeFlyer will key in all of this. And as I mentioned, this software was used earlier this year to support Ghost T and will be used in the future for the Ghost U mission. Thank you very much. Do you have any questions?
Yeah, thanks so much, Daniel. That was a great presentation. We have a couple of questions for you. To start off, the first one is, it seems like in the Excel sheet, you can easily enter an invalid number or invalid value. Was there or did you implement any kind of range or input validation in the FreeFlyer GUI to make sure an operator wouldn't input something that was wildly out of character for what that value was expected?
Yes, we all of these values incorporate inside the FreeFlyer GUI. We have FreeFlyer range validation implemented inside FreeFlyer. As I mentioned before, the entire Ghost FDS software has a MATLAB wrapper, GUI wrapper around it, and that one also has input validation, so we can avoid these issues.
Okay, so there's kind of a two-factor authentication that allowed you to not have an operator put in an invalid value.
Yeah.
Cool. The next one is, did you come across any challenges in recreating the preliminary ascent planner in FreeFlyer?
So I personally did not develop the preliminary ascent planner. This is more by Nate Johnson, which I don't think is here, but one of the parts that I was involved in was the custom GUI. As I mentioned, even though the FreeFlyer script was much more powerful, there were a few things that were nice to have with the spreadsheet. With the spreadsheet, you just change a number, enter a key, and it will immediately update the results. Whereas the FreeFlyer script, we had to run it every time we desired new results, and that was the main driver for adding the custom MATLAB GUI, and which it was very useful that FreeFlyer has this built-in way of talking and interfacing directly with MATLAB. So yeah, I
Okay,
would say that was the main thing that was the hardest to replicate.
gotcha. The next one is, are there any other changes to the Go's FDS currently planned between now and the Go's U launch in 2024?
Yes, there are many updates that rank from small parameter changes to um, finding ways to improve the way we're targeting burns to better match what the spacecraft manufacturers' plans, orbit planning is. Also adding a lot of quality of life tools that make it easier to visualize where a number is not right. I'm trying to think of specific on the top of my head, but a little of that comes down to visualizing in the reports from basically like automation. So we don't have to copy stuff manually from one place to another, but just have things be more automated and in presentation. So it is easier to QA outputs that we have and make sure that everything is right.
Okay. So as you've been working on this mission and then the upcoming Go's U mission, do you feel that mission requirements are getting tighter with each newer Go's mission?
Um, I haven't experienced, I mean, I've started working on Ghost in Ghost T, so maybe I wouldn't be the best example to see if they've been getting much tighter in the future. But the from what I've heard of my coworkers say, operations have been getting smoother. So I do feel that we've been improving.
Okay, and kind of going off the previous question, so you mentioned that one of the big things is trying to replicate what the manufacturer's maneuvering system is like. Have you investigated use of the optimizer in FreeFlyer to kind of replicate the results that the manufacturers are giving you? Are you sticking to the targeter? Yeah, what are your thoughts on that?
Um, yeah, I haven't considered the optimizer. Um, it could be like a good way of trying to match exactly um, what the spaceport manufacturer is providing us with. But so far we've focused because at this point, even if we don't match exactly, the results have been really good, and it has carried us through um, 3 missions already. So um, it could be an idea to try and see, but so far we haven't considered.
Okay, and we have one last question. It's in regards to your 2D map that you showed in your slides. How did you draw those coverage bands, and in that map. Yeah.
I believe this is with the object overlay function. So you're giving, because I did not personally develop the preliminary scent planner, so I cannot guide you in detail, but I believe it was with the object overlay. I can just create those objects in front of the graphics that you already have.